The following is from Fall 2010 Math 227 Test 2 number 5. In this video I will do number 5A and B, maybe with the C. Okay, let's start. The height of students at elect is normally distributed with mean 5.5 feet and standard deviation of 1.2 feet. Now, so let's say let x be the height of elect student. I think I should say an elect student. Now then we know that from the information given to us that x is normally distributed with mean 5.5 feet and standard deviation 1.2. I'll put a square there because that's the position for a variance. Now in this question part A here, find the probability that a randomly selected elect student is more than 5.7 feet in height. Now first thing I will do, I will standardize that. Okay, and this probability of z is greater than what is this? 5.7 minus 5.5 is 0.2 divided by 1.2. That will be 0.17. Okay, but you see that if I want to use my table, the number here is greater than 0.17, right? While the one in our table, give us is the area to the left of that number, right? Okay, now let's see from the table what's that. The area to the left of that, that will be, let's see, 0.17, 0.17, oops, 0.17, 0.5675, 0.5675. So it'll be 1 minus, oops, let me use this, 1 minus probability that z is less than 0.17, which is 1 minus 0.5675, which is equals to 0.4325. Okay, that's the probability that an elect student will have height greater than 5.7 feet. Now part B, find the probability that a randomly selected elect student is between 5.2 feet and 6.1 feet. So we can use the same random variable x, but this time this x should be between 5.2 and 6.1. Okay, I will do the same business. I will standardize that first. That's 5.2 minus the mean over the standard deviation. This is 6.1 minus the mean over the standard deviation. Okay, that will be here, if I compute, I think I will get negative 0.25, and this becomes z, and this becomes 0.5. Okay, now then again I look at the table. Let me sketch the curve first. This is 0.5 here, and this is negative 0.25. We need the area in between. We need this area here. This is the one we need. Okay, so when I look at the table, the area to the left of 0.5 will be 0.6915 minus the area to the left of negative 0.25. If I look at the table, I will get 0.4013. Okay, now if I subtract, I will get, you can use your calculator, this is 0.2902. Okay, that's the probability that a randomly selected elect student is between 5.2 feet and 6.1 feet in height. Okay, let me just go on finishing this question. Part C, find the probability that the average height of 16 randomly selected elect students, I think I should say 16 randomly elect students is between 5.2 feet and 6.1 feet in height. Now, so you see that this question seems to be very similar to part B. Yeah, let me contrast that. But in part C, we are talking about the average height of 16 students. Okay, so the random variable we are dealing with is not this x anymore. It's not this one, but this one. Okay, the average height of 16 students. It's okay? And this will be 1.2 squared over 16, which implies the standard deviation of this x bar 16 equals to 1.2 over square root of 16, which is 4. I think that's 0.3. Okay? Now, then, the probability that this x bar 16 is between 5.2 and 6.1 will be, if I standardize that, probability that 5.2 minus 5.5 over 0.3 is less than x bar 16 minus mu x bar 16 over sigma x bar 16 less than 6.1 minus 5.5 over 0.3. Now this 0.3 here is the new standard deviation, and when I compute, I will get this number here is negative 1 less than z less than, that will be 2. Okay, which if I compute, if I do the table, the curve and then the table, this is negative 1 and that's 2. We need the area in between. Okay, which then, if we look at the table, we'll get the area to the left of 2 is 0.9772 minus the area to the left of 1 will be 0.1587. Now, make sure that you look at your table and match with what I have here. And then when I subtract, let me use calculator. When I subtract, it will be 0.9772 minus 0.1587. That is 0.8185. Okay, now that's the probability. So you see that the probability that a student has height in this interval is actually less than 30%, but once you get 16 students, the average is quite likely that it is in this interval. Okay, now let me go on to part D. As part of its qualification, the elect basketball coach sets a minimum height in hiring new players. Find the minimum height he should set such that only 5% of the student body satisfy this minimum height requirement. Basically, let's say that height requirement is K. Now he needs to set the K such that only 5% of the student population is taller than that K. Okay. Now then what I will do is I will standardize that. This is K minus the distribution of X is the average is 5.5 and then the standard deviation is 1.2. This is 0.05. Okay, basically now we are looking at this. Okay, the area to the right of that has to be 5%. This is 5%. Okay, means the area to the left of that is 95%. Now what is the C-score? What is the C-score for that? Okay, you will see that maybe I twist that around a bit. Probability that X maybe Z is less than Therefore k minus 5.5 over 1.2 now is 95%, right? Greater than that is 5%, less than that will be then 95%. From there, then we look at the table. What is the c-score? The c-score here equals to 95%, 95%. This one here is 1.645. 1.645. It's 1.645. Now that way, then k equals to 1.645 times 1.2 plus 5.5. Okay. If I use my calculator, 1.645 times 1.2 plus 5.5, that would be 7.474. K equals to 7.474 feet. Oh, that's a very tall person. Now, you know, this data that I use here is not a real data. That's a made up data. Okay. Now, that this is from fall 2010, Math 227, Test 2, number 5.